Hey y'all, welcome to lesson 7.3, which is all about the basics of solubility. I assume you know what solubility means or what dissolving means. Probably you've all at some point in your life had Kool-Aid, which basically you dissolve a powder into a liquid and get Kool-Aid. Maybe sometimes you use too much and it gets thick and syrupy. Um, Maybe sometimes you even put so much Kool-Aid in such a little amount of water that it doesn't even all dissolve. Um, anyway, we're going to define some terms and talk about solubility here for a couple of minutes. So, first, some definitions. Let's do this so we have the ones where we actually need to write on. So, a solute, that's our first definition, SOLUTE, solute, is the substance that is dissolved. So, it's the Kool-Aid powder, right? The solvent, SOLVENT, is the stuff it's dissolved in. So in our Kool-Aid example, it of course would be the water. So solute is the Kool-Aid or the sugar or the whatever, and the solvent is the water that you're dissolving it in. Okay. Um, Solvents and solutes can be of all three um, of the major forms of matter: solid, liquid, gas. You can dissolve a solid in a liquid, a solid in a gas. You can dissolve a liquid in a liquid. You can dissolve a gas in a liquid. So you can do all that. When we talk about solubility here in chemistry class, we are talking about water as a liquid solvent, and we are dissolving most often a solid in that water, um, like salt in water. That's a big one that we will talk about. So most often, water is our solvent. Um, and what happens at the microscopic level, if we could look down at the atoms and see the atoms of that salt dissolving in water, what happens is all of those salt molecules break apart and we get the solvent molecules, the water molecules surrounding those solute particles, and they form what are called hydration shells. Hydration, is about water, and you all know what a shell is, I'm sure. So the water basically surrounds the atoms of whatever is being dissolved in it. Um, Sometimes, especially when we talk about ionic compounds, those solutes will break apart into ions when they dissolve. Sugar does not, it just breaks apart into individual molecules because it's a covalent compound. But ionic compounds will break apart into ions as they dissolve. So you can see here in our little picture, before dissolving, here we have our our solute, sorry, is potassium hydroxide. So it's got potassium and hydroxide ions. They're all bonded together because of the positive charge on the potassium, the negative charge on the hydroxide. So this is a powder, right? And what we do, we scoop some of it and put it into the water. Right, the water is our solvent, and we end up with a solution. You can see, well, I guess this is my water, right? It's the solvent. I see the oxygen, hydrogen, water molecules, right? So they're going in, okay? Then that's before dissolving, so they're separate. So then once you dump the potassium hydroxide in the water, what you get is these hydration shells. We'll label them hydration shells around the potassium, around the hydroxide, and so this potassium hydroxide has split apart into its ions when it dissolved and being surrounded by water. Um, Sometimes there are chemicals or things that don't dissolve or don't dissolve very well in water. They are what is called insoluble. So when something doesn't dissolve or it doesn't appear it's dissolving very well, we call that insoluble. So when you have a chemical reaction and you form an insoluble substance, so it's very possible that you could have two things that are soluble, but when you mix them together, they form something that isn't insoluble, that doesn't dissolve. Okay, we call that stuff that doesn't dissolve precipitate. Precipitate. You've all heard the word precipitation. That's when stuff falls out of the sky, right? So we call this a precipitate because it comes out of the solution. That we even say it falls out of solution. I will do some demonstrations of this on video and in class to show you how we can make that precipitate. But basically, instead of it being in solution like in this picture, it falls out of solution just like rain falls out of the sky and creates this solid here at the bottom of the beaker of water. So silver chloride is an example of an ionic compound that is insoluble, right? Very little of it dissolves, not enough to even be noticeable under standard temperature conditions. You have to heat it up pretty hot to get it to finally dissolve. There are also compounds that are soluble. Okay, so when something does dissolve, we call that soluble. Sodium chloride is a great example. Salt, you can dissolve it in water in your house. Do that this afternoon if you want. Make some salt water. But it is very soluble. Okay? A lot of sodium chloride will dissolve in water. You can keep putting it in, keep putting it in, keep putting it in, and it'll keep dissolving for a very long time. It is very soluble.